Hey everybody, welcome to the introduction to the Go programming tutorial. I'm Bill and I'm the instructor for this course. In this course you'll learn everything you need to get started programming in Go. Our goal in this short course is to teach you enough of the Go programming language to get you started writing single file applications. In a later course we'll cover the more advanced topics of Go. For example, writing a CI pipeline for it, doing testing, multiple packages in the same application, etc. So be sure to be on the lookout for it. As far as the prerequisites for this course, I assume that you know how to do basic system administration tasks for your operating system, which is we cover Windows, Mac, or Linux, and those include downloading and installing applications like the Go binaries. Creating directories, updating the path so we can execute the Go binaries automatically. I don't go into detail on how to do these tasks in the course. I assume that you know how to do that. So, I also assume that you have some development experience with some other programming language like Python, C, or C++, or anything else. Some of the basic programming ideas will not be covered in here, like looping and so forth. Now this course will get you started with programming in Go by teaching you the very basics of the Go programming language. So with that, we'll go on to our first section, which is installing the Go programming language binaries. In this lesson, we will learn how to install the Go programming language on Linux, Mac, and Windows systems. We'll also configure our development system to properly compile and test Go-based applications using Visual Studio Code. As you can see in the video here, I'm actually using Ubuntu server or Ubuntu 18.04, but we have instructions here that'll help you get it installed for Windows and Mac also. So for installing the Go binaries, we want to go to the Go downloads page. So let's go ahead and go there. So open up your browser. To go to the golang.org/doc/install. There's a link in the document here for this lesson. And basically you want to go to download Go here and find your operating system and download it. So you can pick either Windows, Apple, Mac OS, or Linux. So what you're going to do is just install that for Windows. The MSI, of course, you're just going to run it, and when it asks you for administrator privileges, go ahead and tell it yes. And install it, and then install the binaries, and also update the Windows path accordingly so that the bin folder will be accessible, and you can run the Go compiler and other tools from the command line without having to worry about what directory you're in. Apple Mac OS has other applications. It'll pop up with the package installer. Drag that over to your applications and it will install the binaries. For Linux, it's a little bit different. You want to untar this. When it downloads, you untar this tarball and then it'll install from there. And there's also detailed installation instructions here that can help you install all those. So also, one thing to check is after you download it, as we have in our lesson page here, you want to make sure that your path is exported correctly. So here I'm just going to show what my path is. At the end, you'll see we have home build go/bin. You want to make sure that is in your path so that you can actually run Go commands like go in lowercase, Go version, and you'll see what version of Go that we're using. Now, depending on how long it's been since I've made this video, your version may be different. That's fine. Well, we just want to make sure that it has something there. And now you're ready to install Visual Studio Code. For Visual Studio Code, it's pretty easy also. You just go to the Visual Studio Code download page. And again, it lets you pick Windows, Mac or Linux. If you're using Ubuntu, you download the dev. For Red Hat, or anything else, you use it RPM. And they also have instructions for downloading and installing those here. Once you get it installed, you will be able to start Visual Studio Code, which I've already got here. And after you install it and you make sure it's installed, we want to go to the extensions icon right here and you're going to type in Go. Well, if I'm actually in there, Golang. Go, and you want to install this one right here that has a star. I already have it installed, of course, on mine. Yeah, now Visual Studio Code is ready to go, and as you can see, we go back to files here. We load a Go program. It's got syntax highlighting, and is ready to go. So now that we have this installed, we'll go to our next section where we'll actually configure everything so that Go will be able to compile and work correctly. Go is very specific on its workspace directories and how they're organized and where they're located by default. So we'll cover that, and we'll also write this program here, which is the Hello World program. As if you've ever seen a programming tutorial, they all have it, and we have one in this course too. So we'll see you over there. Thanks for watching. In this lesson, we will learn about the Go development environment, and we will configure our development system accordingly. So first, we'll talk about the Go workspace. So when you install Go, an environment variable Go path was set that points to the Go workspace. Go path typically points to wherever your home directory is /Go. So we can kind of look at that here. Here's my home directory, and you can see there's a Go directory here in my home directory. So that's where all of our Go source codes and binaries are going to go. We need to make sure that we have source and bin directories in there. So if we change directory into here, and it'll be the same on Windows, whatever your home directory is, and on Mac, whatever your home directory is, there's going to be a Go folder in here after you install Go. So we want to make sure that there's at least a bin and a source directory there. The package directory will get created later on when we install packages. You can create it now if you want, it doesn't matter. So we need to make sure we have at least those two directories in there, the bin and the source directory. Go is very particular about where these directories are. If you want to have your Go workspace in a different location, then you make sure that you update your Go path environment variable. So as an example, let's take a look at our Go path. And here we have it set to home build Go. If I wanted to put it in some other place, like in my development directory, home/development Go, if I wanted to make that my Go path directory, I would update the Go path variable to be to point to that directory, but without the tilde, to be the full, home build development Go. So that would be how I could do export. I'm not going to actually set it on mine because I like to have everything where it is. But you essentially do an export Go path equals home build development Go, wherever you want to actually put it. All of the Go commands and subcommands depend on knowing where the Go path is. So make sure that you have that set. The source folder organization. So if we change into our source directory, it may look a little different. So Go is tightly integrated with Git, and the organization of this folder reflects that. Under the source folder, our folders representing different Git repositories. So if we look here, we have git.admin_tome, and if I do an ls on that, if I do a directory, we can see I have my Go programming tutorial, which is the source code for this very course. I have Go routines, hello, and manage game data, which is another project that I'm working on. But you can see all those which I have pushed to my local public GitLab instance, which is git.admin_tome.com, will go there. Some of the more public ones will be under GitHub. So if we do a directory under that, we can see some of the other packages that I've used in my other projects, and they'll be listed out here. So wherever your Git repository is where your ultimately your source code will reside. So as you can see, the source directory has a very specific organizational structure, and all the Go command line tools rely on the structure to function correctly. So for our tutorial, I have on my GitLab, which is accessible to everybody, so you should be able to get to it. https://git.admin_tome.com. We should see that if you log in, it's actually open to the world, but And I have a link to this on the actual lesson. So if you look here, you'll see all the source code for all the different lessons in here. So we'll start to write our first application. Basically, just gonna copy this and do a git clone in your source directory here. And that will clone it down into into git.admintome.com/hello or /go programming tutorial, as we can see here. There we go. And there's all of our applications here. So let's actually change directory into there. Alright, and now the next section will be writing our first application. Like every other programming tutorial out there, we will be writing a Hello World program. In your terminal, go to the source directory and go to workspace. So actually we want to go from here, since we already have Visual Studio Code installed, we can do code dot. And this will load, let me kind of clear up my screen a little bit. This will load Visual Studio in the current directory. As you can see, here's all of our little projects. We're going to, for you, if you download the source code, just change in the hello directory, and we're going to look at main.go. If you didn't download and you want to write the code yourself, create a directory called hello, and then write and create a new file called main.go. Create new directories and files by right-clicking over here, do new folder or new file to create your files. And so here's our Hello World application. In the next section, we'll actually be doing a deep dive on what each one of these lines means. For now, we're just going to write this, and then we're going to save it. So go to File, and then Save. And then we're actually going to exit, because we're going to compile this and run it. So to build Go programs, we're just going to type in go build main.go. So we're going to tell it go build, and then the Go source file that we created a second ago, which is main.go. Helps if I'm in the right directory. Now go build main.go. Alright, it doesn't show any output, so that's good. But you'll see now we have a binary in here called main. And we can run that binary. We can either do .whack main, and it shows hello world there, or we can even type go run main.go, and let's make it clear, go run main.go, and it'll compile and run it all at the same time. So I believe if we do, actually let's clear it out and make it go build main.go dash out hello. Oh, let's look at the help. Go build dash help, or go help build. There we go. So what we want to do is change the name of the output file that our Go compiler is building. The -o flag allows compiling single packets, forces build the right zone object in the named output file instead of the default behavior described in the last two paragraphs. Well, I believe that's what I did, isn't it? Name files must be Go files. Maybe it's because I have it in the wrong spot. There we go. Now we have a hello instead of main. And if we run that, we get our hello world. So that's a basic introduction into writing a sample source file in Go, compiling it, and renaming it to something more meaningful. That only works for single file source applications. When we get into the advanced Go course, we'll have to do it different. For now, as long as you're doing a single file, you can rename it. Apparently the parameters, it's important to where we have them, so make sure you put them in the right place. And we know how to run our application. So that does it for this section of the lesson. For the next one, we'll go into a Hello World deep dive, where we will go over our source code. In the last lesson, we wrote a Hello World Go application. This lesson will look into more detail at the source code. So here's the source code for that Hello World application. The first line sets the package name, and here we have this set to main. All Go programs start with the main package. We will go into more details about Go packages in a later lesson. For now, just make sure that you have a main file that has the main package set to main in order for it to run. So here we have a main.go and a package main. The next section lists all the packages this file depends on. In this file, we see the FMT, or the format package. This is the format package and is needed to print out output to the console. The last section is the main function, and that is here. All Go programs need to have a main function. This serves as the entry point into your applications. The main line of our application prints out our Hello World. One thing to note is that all functions start and end with curly brackets through these guys. The opening curly bracket must be on the same line as the function definition. For example, you could not declare your main function like this, which you can commonly see in other languages. You get a missing function body error. As we can see here, we highlight it, get a missing function body error, and our code fails to compile. This is different from other languages like C or C++. Another major difference is that trailing semicolons are not required. Yes, you can have them like this, but is not required unless you want to have several statements on a single line, as we'll see when we do for statements in a later section of the course. In fact, if we try to save this, the Studio Code will remove it for us. In this lesson, we will learn how to use variables in Go. Let's update our Hello World application to use a variable for your name. So here we've added this line. In the main function, we have defined a variable named name and assigned it the value of Bill. And we do that with var, and then using the var keyword, using name, and then the variable type, the variable value, which is Bill. Also notice we updated the printf statement to print the variable. The %s, which is right here, is used to signify that the string value of variable after the comma should be inserted here. So this will put the value of name here in place of this %s. And if we run the program, we will see that it says hello Bill, which we get right here. We could also set the variable name like this. So we'll take out the var here, and this is the variable assignment shorthand. Composite variable types. In the last lesson, we learned about the basic variable types in Go. In this lesson, we will learn about the composite variable types. These are variable types that build on the basic ones. First, we'll discuss arrays. An array is an ordered list of variables of the same type. As an example, let's say we want to create an array of strings representing names, which I have highlighted here. Arrays in Go require us to set the size of the array. If we do not set the size, then we are actually setting a slice, which we will talk about in a few minutes. Here we are setting our name array to contain one string. We can now set the first item in the array as a value by using an index, which I have highlighted here on line 16. All array indices start at 0 in Go. As we look at the full listing, we can run this and see what it says. So we get hello Bill as expected. Let's say we want more than one indices, so let's change it to 2. And then we can update this to set the name of the second. Simply save this and run it again. Oh, yes, helps you use the right index. And let's actually change that to print out our second value. Save. And let's run it again. And here we can see our first value and our second value being ran. Well, if we wanted, we could declare it all in the same line, just like you would any other variable. So we could say, but this will make it locally scoped to this main function. Actually, we want squiggly brackets here. We'll get rid of our global decoration. Now if we run it, we should get the exact same output, and we do. So to do this globally, just like we did before, we set our var variable, and we just can remove that, put it up here. Get rid of this declaration. And we'll run it. We should get the exact same output, but now our name variable is globally scoped. Next, we will move on to slices. Here's the source code for these slices. Section slices are like arrays, but are declared without a size since they are variable length. So as we see here, we're setting our name to an empty right here, which means keep it variable, and we can set it to any number that we have. So the thing about it is that we have to. It's a variable length, so we can set whatever number we want here for a slice. To do this, slices let you act on a subset of your data. To do this, we use a slice operator variable, which is I:(j), which we can see here on line 16. I is the starting index and j is the ending index. So here we can say we're starting with 1, the index 1, and ending with index 2. So for our example, we could select Ted, which is index 1, by using this code like I have highlighted here. This tells printf to start with the name index of 1 and stop at index 2, non-inclusive. So if we wanted to include it, we'd have to. I'll show you here in a second. So if we run this now, you see we get just plain old Ted. So if we want to return all values from the beginning to the ending index, again non-inclusive, we could take out this, and that'll mean start from the beginning and go to whatever the final index is. So if we save this and run it, you see we get Bill and Ted. See if we can get them all. Nope. It's not like that. There we go. So you just don't do an index on there. So to return the first two, we get :2, :2. We'll start at the beginning. Goes to index 2, not inclusive, so we get Bill and Ted. Or if we want to go from an index to the end, we could change it to something like this. It's very similar to other languages like Python. We get Ted and Frank. And we can append a value to a slice using a built-in function called append. So here we have our name variable. And let's add a new value to it. Append. Do the slice that we're appending to. The new name, which is Bob. We're going to do just Bob, and this looks pretty much like an array where we're calling a single index. And here we should see hello Bob. On to our next composite variable type, which would be maps. Maps are how hash tables are represented in Go. So to declare a map, we use the map keyword with the key in brackets and the value afterwards. We use the built-in function make to make an empty array. So here we actually have a global variable set up of level, set up as a map, and we're telling it that the key is a string value and the value is an integer. So we'll define these. So we have Bill and 25, Ted 1, Frank 8. So these kind of represent the levels that these, I guess, characters are at. And to access it, we just give it the key value, and this will give us the value. So level Bill should give us the value of 25. So if we save and run this guy, it says Bill, you are level 25. The next composite type we'll talk about are structs, or structures. A structure in Go is an aggregated data type. It lets you combine values of differing types into a single type. So if we look at our code here, we have a car structure. So we say type. Notice this is different. This is not the variable section. So we have type car, and defining it as a structure. And we have two values here. We have wheels as an integer, and color is a string value. So we're going to start out by declaring a new variable of type car called Camaro, and then we can set the values for the different variables inside of our structure. So we have Camaro.wheels equals 4, Camaro.color equals black. And then notice this matches a string and an integer. And we print those out using the same dot notation. Your Camaro has %v wheels since it's an integer and is %s. So we'll say Camaro.wheels and Camaro.color. So if we save this and we run it, it says your Camaro has 4 wheels and is black. Structures are very powerful with Go. Like most programming languages, you'll need to control your application. In this lesson, we will cover how to control your application using if-then commands, for loops, and more. First, we'll start with the if statement. We will look at the if statements for controlling our program. Let's look at how we write an if statement in Go. So as you can see here, we got if and then an expression and then curly brackets. And then there's our code if that expression is true. And then we close the close brackets and put else if there's another expression. And we can continue with more ifs and else. Here's a full program listing for the if else control. So here we have package main. Like always, we import our format so we can print stuff out. And in our function main, we configure a variable named level, and we set that to a value of 25. We create another variable called response. It's going to be a string. And here we're going to do some testing. So here we have if level is greater than 20, which in our case it is. So it'll run this block here. It'll be response equals high level. So we're going to set our response to high level if our level is greater than 20, which ours is. If we didn't, then the next part would hit, and that's the else. If level is less than or equal to 20, it would set the response to low level. And then we close out of that if statement. Then we use format.printf to print out what our level is. It's also a default else. You can put a default else at the end that will act as a catch-all. Also notice that the first expression is compound in that we have two expressions that must match in order to run the code block immediately following it. You can use logical AND, which is ampersand ampersand, or logical OR, which is two pipe characters. So here we see our main function again. We have our level set to 32 now. Our response is still a variable, which is a string. So our first if statement is checking if level is greater than 20. If that is true, then it also checks to make sure that the level is less than 30. If both of those are true, then we'll run our next block of code, since we're using logical AND. In which case ours is not, so it will skip over this bit of code and not set the response equal to high level. We'll move on to the next part, which is else if level is less than or equal to 20. It will set the response equal to low level. Ours is not, so we're going to fault through to the default, which is set to else. So anything that is greater than 30 will hit here. And we'll set our response equal to super high level. And you can see that's what our output shows. Your level is super high level. And we'll move on to for loops. Most looping and iteration is done using for loops. Looking at the following code for a basic for loop in Go. So here we can see our packages main again. We're importing the format package so we can print stuff out. In our main function we have for x is set to 1, and then put a semicolon. Remember in the previous lesson, this is where we're combining statements on one line, which is perfectly acceptable for the for statement. And this looks pretty similar to other languages like C++ or even Python. So we have our for, and we set our x value to 1. The next statement is our expression. So as long as x is less than 4, it's going to run this block. And each time it runs the block, it's going to bump x by, it's going to increase x by 1, which is at x plus plus. So each time we enter the loop, we're going to print a line. So essentially what we're going to do here is print out 3 lines, which is you can see the output of this code at the bottom there, which is print a line, print a line, print a line. Iterating over enumerated types. To iterate over an enumerated type, like an array, we could use a for loop. There are a few things to note in a for loop. We are using the range keyword that will be used to iterate our array nums. Range is a built-in function that returns 2 values. We'll see more of this later in the functions lesson. Range will return the current index and the value of the range at that index. For arrays, indices start at 0, so when we run the program, as we will see, that it starts at 0. So here's our program listing. We're using again the package main. We're importing our format package to print stuff out. And in our main function, we have a variable called nums that we're setting to an array of integers, and we're hard coding those to 1, 2, and 3. Now our for loop. For our for loop, we assign the variable x to equal the range of nums. So it's going to go through each one of those nums, and we're going to print out the line where it prints out the value. And as we see here, as we see the output when we run it, it says print line 0, 1, and 2. This is because by default it's going to return the index, not the value of the variables. If we want to see the value, we'll look at the next slide. For loop index value. Now we can alter our for loop to output the value like this: for x, y. We're going to assign both of those values to whatever range nums returns. The range actually returns 2 values, and as we'll see in functions can return more than one value. In this case, we're returning the index and then the value. So x will be our index, y will be our value. As we iterate through that, we will print out the print line, and then %v is going to be our index with a value of %v, which is y. And as we can see in the output, it shows 3 lines that have 0, 1, and 2 for the index, and then our values of 1, 2, and 3. Most of the time we don't really care what the index is, we just care what the value is. Go has a special character for that, which will ignore the value that we place there. So as you can see in the next next bit of code, we have for underscore, y equals range nums. It's very similar to the first bit of code, but we have an underscore there in place of x. That basically means we don't care what x is, just in Go, you have to assign the value. If it's the first value there, you have to put something there. So this is like a placeholder, which is like a throwaway variable. And we're just going to print our line that has all three values. So this will print our values for our variables in our array, which is our desired output. Now, how do you do while loops in Go? In Go, we use the for statement to act like a while loop. To use the for statement like a while statement, as you would in other languages, you write the statement like this. So we have our package main, we importing our format package, and then in our main function, we set a variable of num equal to 1, and then we set for num is less than or equal to 3. So basically this is while num is less than 3, less than or equal to 3 kind of loop. And then we'll print out each line, increasing that each iteration, doing num plus plus. Notice we have our expression after the for statement. In our for block, we need to increment the num value in some way. If we don't, we get an infinite loop. Notice also that we can increment an integer variable by using the plus plus operator, just like some other languages like C++. This is desirable if we have some way to break out the loop. Let's look at that in the next slide. To break out of our for loop, we'll look at this program. So we have our package main. We're importing our format package so we can print stuff out. We have our main function. So we have our variable input, which is going to be a string, and we have a for loop, which you can see has no expression, so it's basically an infinite loop. First thing we're going to do is print out a line that says enter your name, and we're going to use another function in the format package called scanLine, which is going to take input from the keyboard on the console and assign that to our variable of input. If input equals stop, so if we type in after it asks us to enter our name and we put in stop and we hit enter, it will fire off this if block, which says to break. Break is the statement we use to break out of whatever loop that we're in and continue executing the code. If it's anything other than stop, then we're going to print out you entered whatever the value is of input. So when you run this program, it will asks you for your name. You put in your name or in multiple names, and it'll keep going forever and ever until you input stop and press enter. Now on to switch statements. Sometimes when writing a program, we will need to branch our execution in many different ways depending on the value of a variable. Take this following bit of code that creates a menu and waits for a response. So first we're going to print out our menu items, which is select an option. Menu 1 is add numbers, option 2 is subtract numbers, option 3 multiply numbers, option 4 divide numbers, and we'll print all those out. And much like before in the last bit of code, we're going to use format scanline function to return back what we want, which is our result. So if result equals 1, we're going to do addition, else if result equals 2, so on, which is a whole lot of if-else statements, which isn't very clean. So we're going to use our switch statement to make that look much cleaner. We can simplify the code using the switch statement. Here's our newly formatted menu using the switch statement. So here we print out our menu again, and this time we're using switch result and equals scan line, and we're going to say result and do the open curly bracket there, and then we say case 1, do addition, case 2, case 3, case 4. If none of those match, then we do our default, which is got back an incorrect response, so we'll probably throw some kind of an error here. So these are the basics of controlling your Go program. Go is centered around functions. Functions let us break our code into easily manageable slices. We define functions much like our main function in prior examples. Let's write a sample program that uses a function. Here we define a new function called sayHello, and we call it from our main function. So we start out a function declaration with the function keyword, just like we did in the main function, and then we give it a name, and we open and close parentheses, and we start with the squiggly just like we did main. And here we're just saying format printf hello, world, just like we did in our hello world example. So to call our function in our main function, we simply use the function name with the parameters of open parentheses and close parentheses. Here we have no parameters, so it's just no value in between those. Running this, we get the same output as our hello world application, which just says hello world. function parameters. We could make this more interesting by adding functional parameters. Let's change our function to take a name as a parameter. Here, when we have our function declaration of say hello, inside the parentheses we have name and string. Our name value is with a string variable declaration. So here we're expecting a name that's a string, and then we print that out with our format packages printf statement with the %s in there, so it does a string, and we use our name variable. And in our main function, we assign a variable called name, and we set it to Bill, and we pass that variable to our say hello function, which will say hello Bill when we run this program. One powerful feature of functions is the ability to return values. Let's change our function to return the formatted string. So here in our say hello, we have a string and an age, and after the parentheses we have a string declaration, and this is what type of variable it is that we're returning from our function. Inside the variable declaration, we create a new variable called result, and we use format.sprintf, which is a function which is going to return a formatted string without printing it anywhere. So here we're saying hello %s, which is going to be our name variable, %v, which is an integer value it prints, which is our age, years old, and it returns that string variable of result as a return value of our function. So in our main function, we create a new variable called name and assign it the string value of Bill. We create a new variable called age, which is an integer, and we set that to 21, and we set our message to the result of the return value of our say hello function, passing that as parameters our name and our age, and then we print the result message, which in this case would be hello Bill, you are 21 years old. We can even return multiple values from Go functions. Let's see, another powerful feature of Go is the ability to return multiple values from a function. This is normally used to return any error message, but it can be used for anything. Let's change our function to perform some validation. So in our say hello function here, we still have the same parameters of name, which is a string, and age, which is an integer. But notice where we have the return value, we no longer have just string, but inside parentheses we have string, error. This tells Go that we're going to be returning two values, one's a string and one's an error. Inside of our function declaration, we have result variable, which is set to an empty string. Next, we test the length using an if statement and the built-in len function to test the length of our name string and see if it's greater than 5 characters. If it is greater, then we return our result, errors.new, which is a function in the errors package, which is going to send back an error. And here we're telling it your name is too long. If it's not, then we go using our same code as before, creating a result variable and assigning it that value of hello, whatever the name is, you are whatever age, years old. And then we return result, nil. Nil is a special keyword in Go that's a blank value or a placeholder. So here we're saying there's no error, and it returns back nil. So in our main function, we declare our name variable as William, which as you can see is more than 5 characters. Our age is 21, and here we're saying message, error equals. So when we have our variables separated by commas like that, that means that we're expecting two variables to be returned, or two values to be returned from our function when we call it. And we assign those using say hello, using our parameters, name and age. If error is not equal to nil, which means that error, that ERR variable, returns something other than nil, we want to print out that error and then continue on. If it's not nil, then we're going to use format.printf in our message, much like we did before. That concludes our quick introduction to Go functions. There is a ton more about it. Be sure to check out our next course, which will be the Advanced Go Programming tutorial, where we'll go much more in depth into Go, including more on functions, object-oriented programming, using interfaces and methods. And we even go into testing, how to test our Go programs, and also how to use continuous integration or continuous delivery to automatically to test and deploy and build our Go applications using Jenkins CI and Docker containers.